So therefore, it's important that you have a dead time between them, and then you have a high and a low. So low obviously is bigger than your high because it accommodates your dead time. Okay, so these are things we have to keep in mind. Now, the dead time takes away also from the voltage. That is a time when your duty cycle does not convert into output voltage. That means that voltage is not available to the motor. So you have a net reduction in available voltage to the motor when you have a dead time. So least amount of dead time is preferable, but then you also have to keep in mind your switching. If your switching is not very fast, for example, if I'm using IGBTs for switching, I need to have at least 2.5 microsecond duty time, dead time. If I'm doing MOSFET, I may be able to get away with 1 microsecond dead time. If I'm using gallium nitride, I may be able to get away from with 0.5 microsecond dead time. Okay, less than that time, the better it is in terms of getting more voltage available to the motor. So here is your full half-bridge three-phase inverter, where your goal is really to model these currents A, B, C. They have to model in such a way to extract maximum performance out of your motor. Okay, how do you model them? How do you control them so that you get the maximum performance out of the motor? That's the key. And the key is obviously understanding the motor characteristics properly so that you can model these currents properly. So this is a very useful formula where how you convert your duty cycle into your voltage. Okay, normally the formula we use essentially based on the half bridge configuration, where you can imagine a winding connected between half point of the DC bus, because that's where your neutral point is normally, right? And these two switches. So formula comes out to this way, where if your duty cycle is 50%, okay, if the duty cycle is 50%, you're going to get zero voltage across the motor, okay? And if your duty cycle is 1, you're going to get VDC by 2 voltage across the motor. If your duty cycle is 0, you're going to get negative voltage across the motor.